Hello there. Today we'll be doing a graph problem called alien dictionaries. This is a pretty tough problem, if I do say so myself. Just be warned, there's going to be a lot of intricacies that we'll be going through. If it doesn't make too much sense, it's probably because I don't have too good of a grasp on this question as well. And yeah, we'll see. So this is number 144 of 157. We will be doing this on Leetcode because Leetcode Premium is required for this particular problem. Right, in this particular problem, what we're trying to do is that we're given this particular list of words, and what we're trying to do is find the lexiconic order of these words. We're going to be using a requirement is that we'll start with the smallest lexiconic order if when necessary, and pick that one. And what does that mean? So let's go through an example because this problem is going to be slightly difficult. So so we have these orders here, as you can see, and it looks like F. When we go through this order, we check the first word and the second word, and when we find a difference, this is a T comes before F, so T comes before F. That's just from this particular example. Then we check these next two items, and we see that W comes after E, so comes before E. So W points to E, and then E and R comes before T, so R will go before T as it will point to T. As you can see, this is already a graph type problem, and we are pointing from one to another, and we're linking these up. And as you can see, the next particular problem here is E and then R, and then so E comes after R, so E will now point to R. And this is a pretty straightforward problem here, and with that, we don't have any cycles. But if we supposedly put ETT in here and we see an E again, R will point to E, and that would cause a cycle, and that would mean that we're on the path, and that's invalid. So we're going to be using a lexiconic topological sort for this. Right. Anything else about this problem? Hopefully that should be everything. Oh, right. Another restriction is that if they're of the same length and one's longer than the other, we know that that is invalid if they're the same. So suppose this is WT and this is EE. So this is longer than this one. That means it's invalid. If it is invalid, then we return nothing. Yeah, that should be all. Great. So let's do this. Let's build up the adjacency list, and then make sure that it's on the same path. Okay, when we're making sure this is on the path, what we're gonna do is that we're gonna make sure that that we are looking at the item properly, and so that means we'll be doing this top down, and that basically means this reverses the order and bottom up, and giving us a post order, and that eliminates a possibility of us causing a problem where suppose we have AC. Okay, AC. Oh, okay. And a BA and BC. So as you can see here, if we point directly from A to C, and then B to A, and then from B to C again. What's going to happen is that we have this particular issue. So we have an A points to a B. Sorry. At points to a C, but we're already pointing to C already. So that means that A is pointing to C already. And so that's going to create a cycle, but this is correct. There's no problem here. So A, B, C. Anyways, I don't think that's an issue. Okay, never mind, my bad. All right, so let's just get back into it. Topo sort, make sure it's on the path, and no cycles. One last thing to do is that we're going to do this in reverse order because that way we get the smallest items first. All right, good, let's go. So, adjacency list. So we're going to get every single character. And for I in range, so we're going to get every single word, the thing that we just did earlier in and in person. So we get both words. Then we find the min length between the two. Afterwards, if length of word 1 is greater than length of word 2, and word 1 min length is equal to word 2 min length, that means that this is not in sorted order, and this requires us to return empty string. With that, we're going to do J in range min length and find that particular location where there is something that is different. So once we find that something, what we're going to do is add that to our adjacency list, what we just did earlier. And with that, we will then break, because we can only find one difference, and once we find that one difference, that's where we'll add the character to adjacency list. Once that is done, we are now going to check the paths, right? So so we're going to create a visit. So these are items that we have visited. If it's empty, that means we have not visited. If it's false, that means we have visited in the past. And if it is true, we're on the path, and that means we're in a cycle. So result is equal to empty. Right, BFS of the C. Here we go. So if C in visit, and it is true, then return visit C. Visit C is equal to true for neighbor in adjacency list. So these are all the items that are, let's say, going to be a bigger item than this particular item. So if BFS nay is true, then return true, and we can short circuit all of this. While otherwise, we are done with this, and we can say visited is C is equal to false. So once that happens, that means we can append C. That means this is in correct order, this particular item. And we can now assign it into our results. So with that, everything will be assigned in reverse order. And one thing to note is that we need to process these in reverse order, the keys, because we want the smallest items first. So we want to do the biggest items, and so the smallest items come first. If DFS C, return empty. And now we have we can reverse our results and return empty dot join reverse result. Of course, this is commented out. Run the test. We have an issue. Where is it? Right here. Run the test. Okay, C. Where is C? Range is not defined, line 15. Come on now, let's see. Word is not defined. Of course. Alright, everything looks good. Let's submit. And we have completed this particular problem. This was a very tough problem. One question would be like, how do you figure out that this is the way to solve this problem? And well, first of all, what we did was that we went over and found out how we processed it like a human, and we found out by processing in this way, we could eliminate results here. One, where one is longer than the other and they're of equal length, and two, where we can build up adjacency lists, and three, we checked where we could remove the items. And why we chose to do a DFS, I mean, sure, we could do it BFS and choose the smaller one. Of course, that would also work because, I mean, if these were separated on two different levels, we could just, you know, grab one or the other. It doesn't really matter. So we could do this BFS, but with the DFS, and how we know we needed to use the reverse order and everything, well, I think that comes down to what we're most comfortable with. Of course, during an interview, I mean, we will try anything and everything that see if anything more sticks at this particular point. Regarding the topological sort, I think DFS is the way to go. Anything else? Yeah. So pretty interesting problem. Difficult, definitely. Because of the nuances of the DFS and understanding how that works and how that process just inherently works, how it runs top down and it returns back up, bottom up. And yeah, that's pretty fun. It requires a lot of inherent knowledge, this particular problem. So I recommend doing more DFS problems and until it kind of just makes sense before this applies. So tough problem. I think you see the entirety of the code in one screen. I think not. Let me just give it right here. All right, that's all. So hope you enjoyed this video. Like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.